MCV for U1, Chapter 5, Session 9. In this session, we are working on Section 5.4 from the textbook, the derivative of sine of x and cosine of x. We can use table of values and show limit of sine of x over x as x approaches 0 is 1. Knowing this, we can find derivative of sine of x using first principle. If f of x is sine of x, f prime of x would be limit of sine of x plus h minus sine of x over h as h approaches 0. If we expand sine of x plus h, we have sine of x cosine of h plus cosine of x sine of h. Therefore, the derivative would be limit of sine of x cosine of h plus cosine of x sine of h minus sine of x over h as h approaches 0. We can split this limit in two parts. Limit of sine of x times cosine of h minus 1 divided by h as h approaches 0 plus limit of cosine of x sine of h over h as h approaches 0. Since h is independent variable here, sine of x is considered constant. Therefore, the derivative would be sine of x limit of cosine of h minus 1 over h plus cosine of x sine of h over h. Limit of 1 minus cosine of x over x as x approaches 0 is 0. To show this, if we times it by conjugate and divide it by conjugate, the limit would be the same as limit of sine squared of x over x as x approaches 0. Limit of sine squared of x over x as x approaches 0 is the same as limit of sine of x over x as x approaches 0 times limit of sine of x as x approaches 0, which is 1 times 0, and it is 0. Therefore, we can say limit of 1 minus cosine of x over x as x approaches 0 is 0 using the fact that limit of sine of x over x as x approaches 0 is 1. Therefore, our derivative would be sine of x times 0 plus cosine of x times 1, which is cosine of x. This means derivative of sine of x is cosine of x. We can prove derivative of cosine of x is negative sine of x. If we apply chain rule, derivative of f of g of x is g prime of x f prime of g of x, then derivative of sine of f of x is f prime of x cosine of x, and derivative of cosine of f of x is minus f prime of x sine of x. Let's find derivative of y equals cosine of 3x. This derivative would be 3 times negative sine of 3x by chain rule. That means derivative of cosine of 3x is minus 3 sine of 3x. Derivative of y equals x sine of x. If you use product rule, dy dx would be dx over x times sine of x plus x times derivative of sine of x with respect to x. Derivative of x with respect to x is 1. Derivative of sine of x with respect to x is cosine of x. Therefore, derivative of the given function is sine of x plus cosine of x. Let's find derivative of sine of x2 and sine of x to the power of 2. We use chain rule to find derivative of sine of x2. If we call x2 u, then dy dx is dy du times du dx. dy du is cosine of u. Derivative of sine of u with respect to u is cosine of u. du dx is derivative of x2 with respect to x, which is 2x. Therefore, derivative of y equals sine of x2 is 2x cosine of x2. We could say x2 is f of x, and we use the fact that derivative of sine of f of x is f prime of x cosine of f of x. Derivative of y equals sine squared of x. This can be written as sine of x to the power of 2, and we can use the power rule for a function. Derivative of sine of x to the power of 2 is 2 times sine of x to the power of 1 times derivative of sine of x, which is cosine of x. The textbook wrote this as in the form of chain rule, y equals u2 when u is sine of x, dy dx equals dy du times du dx, and the final answer would be 2 sine of x cosine of x. Next example. Determine the equation of the tangent line to the graph of y equals x cosine of 2x at x equals pi over 2. We plug pi over 2 into the function. The y value is negative pi over 2. Cosine of pi is negative 1. We find the derivative of the function using chain rule. 1 times cosine of 2x minus 2 sine of 2x times x is the derivative of the function. By plugging pi over 2, slope is negative 1. Therefore, the equation of the tangent line is y plus pi over 2 equals negative x times negative x minus pi over 2, which is y equals negative x. Last example. Determine the maximum minimum of cosine to the power of 2x on interval 0 and 2 pi. Without using the derivative, we know the maximum of this function is 1. Cosine of x is always between 1 and negative 1. Therefore, the maximum of cosine squared of x is 1 and its minimum is 0. To use calculus, we find the derivative. Derivative of the function is negative 2 sine of x cosine of x, which is negative sine of 2x. If we set it to 0, x would be 0, pi over 2, pi, 3 pi over 2, or 2 pi. Then we plug these numbers into the function, and we'll see maximum of the function is 1 when x is 0, pi, or 2 pi, and the minimum of the function is 0 when x is pi over 2 or 3 pi over 2. The graph of cosine squared of x is in this diagram. In summary, in this session we learned derivative of cosine of x is minus sine of x, derivative of sine of x is cosine of x, and if we use chain rule, derivative of sine of f of x would be f prime of x times cosine of f of x, and derivative of cosine of f of x is f prime of x times negative sine of f of x. Next session, we are solving questions from exercise 5.4, question 1, part I and J, question 2, part C, E, and F, question 3, part D, question 4, question 5, part B and D, question 7, and question 12. Thanks for watching.